Good morning. You're welcome to today's lectures on pharmaceutical calculations, BDT 253. And we'll continue from where we stopped in approximation, rounding, and what? Estimation. So I think the next thing we'll talk about is the rules of rounding. Rules of what? Rounding. Can this be, can it be landscape? You don't know what is landscape?
Are you going to
Can it be like this? Do it so that it can be like that. Because that is too tiny. Okay, portrait. Na-ebuyara gbagba fon, nwere ihe ma na fon na-ebuyara. Chinenye. Iburu gbagba fon na-akpagharị. Okay. Okay, let's see. So, rules of rounding. What I will do is this. I will just okay. The first one, I think I've mentioned this one to you in this class. When I told you something that has to do with measuring. If you measure a particular length with a meter rule, and you come and tell me that what you measured is 11.56. That is not true. There's no way you can use a meter rule that has the smallest calibration, the smallest graduation there as 0.1 cm. You're telling me that you use it to measure a length and you are getting, let's say, 10.56. It's not possible, because the decimal places should be the same with the accuracy of of the instrument you are using in measuring. So now, as you can see, look at this one. He said that when running a measurement, retain this your full name. I try to make okay, don't worry. I've seen it, don't worry. I've seen it, don't worry. Permit me, I'll put your phone on flight mode so you can okay, good. All right, I said that when rounding a measurement, that you should retain as many figures as we give only one uncertain. We talked about in a measured number, right? That's we have whatever follows before the decimal point is not certain, right? Right? Remember when we say it may even be a whole number anyway. So far it is measured. We gave an example of 325 gram, where we say that 5 gram there is not actually a whole number. It is uncertain. Am I communicating? It is an approximate because of image. Edu, are you okay? You should go somewhere that is so you don't receive so much distant breeze. Go somewhere, at least maybe behind somebody or close to somebody. Not exposing yourself. You can be blessed in their midst, so you can be protected. Now let's continue. So then I said, okay, now using a ruler calibrated only in full centimeter units, it will be correct to record the measurement as 11.3 cm, but not as 11.32 cm, because the 310 there is uncertain, and no figure should follow it. The 3 there is uncertain. Now, another point I want to make is this: once a number is uncertain, especially those in the decimal, if you have something like this, 11.3 cm. If you have a number like this, 11.3 cm now. Which of them is uncertain here, and which is absolute?
11.6.
But this one is what? 11, right? This place is what? Absolute, right? And here is what? Approximate, right? And what? Uncertain, okay? Now, I told you that if you are using a meter rule that is graduated in full centimeter, what it means that if you get it in full centimeter, what it actually means is that the accuracy of that rule is what? 0.1 cm. That is the meaning that this is accuracy of that meter rule, 0.1 cm. And this one is what? You cannot have any other number, any other figure behind this. You can't have any figure because this is graduated in full what? Centimeter. So anything behind this is wrong. But because this is what? Uncertain. This is what? Uncertain. It's an approximate. Okay? Okay? Now, this is for the one that has the decimal point. But we talked about 325 grams when we talked about the what? Weighing. Okay? Now, another point I want us to take note of is this. Of course, you are familiar with this one from your primary school. Or let me say your secondary school. It says when eliminating superfluous figures following a calculation, that is the figures you don't, maybe it's not your target, you want to remove it to get the approximation you are looking for. Okay. Now, when eliminating superfluous figures following a calculation, add 1 to the last figure retained in the calculation if it is what? 5 or more. We'll be doing that, right? So if you let's say if you have 11.5, and depending on what you want to achieve, if you want to approximate to the nearest whole number or nearest whatever you want to approximate it to, this should be what? Because this is up to 5, right? Now it becomes what? You call it 0, right? Then add 1 here, right? So it becomes what? 12. In this case, did you round up or round down? Round up, right? Yes. Good. Now, that's what I'm saying, that when eliminating superfluous figures following a calculation, add 1 to the last figure retained in a calculation if it is 5 or more. For example, 2.43 may be rounded as what? 2 point what? Rounded as what? Okay, if you, let's assume you want to round to 1 decimal place, for example. Now you are rounding down. True of us, you are actually rounding down. You are rounding down. But this one here, you are what? You are rounding up. Now, then if you have 2.46, you round up. True of us, yes. And get what? 2.5. You round up and get what? 2.5. This place is not good for those that have catarrh now. Catarrh and any sign of upper respiratory stuff, malaria, everywhere is open. Now let's continue. Now let us go to another rule. I want us to. We are familiar with all these rules I've been calling since, but let me move a bit. Of course, we treated approximate number now. So anytime absolute number is mentioned, you know what it means. And anytime approximate number is mentioned, you know what it means by now. Now let's continue. When adding or subtracting approximate numbers, include only as many decimal places as are in the number with the fewest decimal place. It didn't say absolute, it says approximate number. So if you want to add approximate number, you should do this. You should retain as many decimal places as are in the number with retain. You should include as many decimal places as are a number with the fewest decimal places. Let me break down this long story. This long story says that let's assume you have an arrays of approximate numbers, decimal, something like there's an array of number here. Let me list them out. You have numbers like based on what we have here. You have 1 says 2.4 what gram. Okay. Then you're adding. Then what next one is align decimal point. Hope you know. 4 489 0.4 what 89. Can you see the board? Those there? Yes. Oh, good. Okay. 0.489 gram. Next one says 0.1875. 0.1875 what? 75 what? Gram. Next one says 120.78 gram. 120.78 gram. Next one says, I think that's all. Now see what this long story is talking about. You know, you have this. All of them are in different decimal places. This one is in 1 decimal place. This one is in 3 decimal places, 4 decimal places, and 2 decimal places. They are saying that if you are adding up this number, at the end, the answer you will get on adding them, after adding them, the decimal place of the number of the answer you get should be in the same decimal place with the number here with the least number of what? Decimal places. So the one with the least decimal place is what?
2.4.
So if you add it, please you must round up or round down as the case may be to the number with the same number of decimal places with the one that's what has the fewest decimal place. So now that means if you add up this now, the decimal place should be in 1 word. The answer should be in 1 what? 1 decimal place. That's what the story, the grammar is talking about. That's what the grammar is talking about. So if you add up this now, what do you get? You get to let's okay. Add it up. What's the answer? 2 what? Okay. Two eight what? 283 point what? 8565 what? 5. This is what you got after calculation, but the answer should be in what? 1 decimal place. So you should what? This you add 1 here, right? Yes. You have what? 283.9 gram. That's what this rule is saying. And if you have number like, please look for the one with the least decimal place. So the answer should be in that the same decimal place with the one that will have the least number of what? Decimal places. For approximate, of course, measured numbers, approximate numbers. The point I want to make now, I think. Sorry. The point I want to make now, I think I have made the point before. There's a point I want to read something. Just listen. It says, however, when an instrument has the capability to weigh precisely all the what? Quantities in such a calculation, rounding may be deemed what? Inappropriate. I think I mentioned this. In pharmaceutical, you know, we are dealing with what? Denominate numbers. Instead of rounding, look for the equipment that have the precision to weigh what you are doing, what you want to do, what weigh. Like now, let's assume these things now. Look up. Let's assume this thing now. You know the diagram, they are denominate numbers. Let's assume you are formulating something in the lab. You are compounding in the lab. And these are the weights of different what? Ingredients you are using for the what? Compounding. You don't need to be told that for you to weigh 0.1875 gram, for you to weigh 0.1875 gram, you should look for a weighing balance that has the accuracy that can weigh this thing. That has the precision that can weigh this thing. And the only one, if you look at the way this thing, the balance, you see it's written there. You see, for this one now, the one that can weigh this 0.1875 gram is the one that has this precision, accuracy of 0. What? 0 what? It must have the same number of what? Decimal what? Places. Now, the one that can weigh this comfortably, the one with 0.1 can weigh this one what? Comfortably. Now, for this one now, the one that has what? 0.001. This one, the one that has what? 0.01 gram. I think you have this one in the lab. We have this one in the lab. You also have this one in the lab. Triple beam balance can weigh this comfortably. I think so. Now, the point there is this. Instead, you know that these things are ingredients. I'm explaining what I just read now. These things are ingredients. So because you don't have the equipment, you go and start approximating this. You have issues. You are approximating the ingredient you want to use in preparing. At the end, you prepare nonsense. Because you'll not be able to get the strength you're looking for. True of us. So what if the ingredient, what if the active ingredient that is highly potent, then you keep causing trouble because you are approximated. Because instead of you are coming to go and look for weighing balance that can weigh this one. You now approximate to 0.19. It's a serious problem. It's a serious problem. Because that 0.01 is a drug. You are either losing or you are adding more excess. Because if you round up, you are adding what? Excess. True of us. If you round down, you are doing what? The strength will not be complete. True of us. So that's why in that's why you have in chai when you in the password chai. I forgot me. Now listen. This I want to read out something that I will throw more light on this. It says, listen carefully. In this regard, there is an assumption made in pharmaceutical calculations that all measurements in the filling of a prescription or in compounding a formula are performed with equal precision by the what? Pharmacist. Thus, for example, if quantities 5.5 gram, 0.01 gram, and 0.005 gram are specified in a formula, they may be added as if they are precise what? Weight. And the sum of what? 5.515 in actual compounding. You add it up, 5.515 gram. You look for what to do what? Measure it. You don't just go and start doing what? Approximating. Using your general mathematics. It doesn't work in all circumstances. Because the number has been what? Denominated. True of us. They have units. It's weight of something that you are approximating. So it's risky. It's not a good practice when you are compounding. Not just when you are compounding, even in other aspects of in other discipline, in other professions. Am I communicating? Because that so far the number has been denominated. Be careful with what? Approximation. Be careful with what? Approximation. Okay, let's assume somebody measures here. Okay.
So, just in case when you ask overage and approximation.
Overage is a different thing, not together. Don't worry, becoming that when we go to reduction and formula, you understand that perfectly, okay? Okay. They told you that in your lab, in the lab.
Yes.
Okay. It won't explain there. Was it explained? In the lab? It was explained.
In case, so you get.
Don't worry, I don't want us to be done. When we go into reduction and the enlargement of formula, we'll pull down there and explain that, okay? Yes. You don't just carry any amount and put and say you're putting over it. It should be proportional. It should be proportional. Let us not go there. Now, so I was saying something before Ifi. Before Ifi ask a question, not interruption. Okay, let's continue. Now, we've talked about when adding or subtracting appropriate numbers. Now, let's look at when multiplying. Please, can you hear me now? Tell me exactly what you are doing. Oh, what are you doing? What are you doing? Let me see your hand. I know, I'm not going to talk now. But what were you doing since that you didn't eat it? Now you want to eat it. The time is 11:27. What have you been doing? If it's our early morning class, I would have allowed it, but this is wrong. What have you been doing since? You are now in lecture, you want to eat it. And you are divided with, the mind is divided now with the biscuit. Three things now. You are battling with the lecture, you are battling with eating the biscuit, and you are battling with me catching you. 3 distractions. Now let's continue. Okay, when multiplying or dividing 2 approximate numbers, we have talked about addition and subtraction. When multiplying or dividing 2 approximate numbers, retain no more significant figures than the number having the fewer significant figures. Retain no more significant figures than the number having the fewest significant figures. For example, now, if you are multiplying, this one says you are multiplying 2 approximate numbers. If you multiply 1.6437 by, if you multiply 1.6437 gram by 0.26, I want to ask a question now. You know, I say that if you're multiplying or dividing 2 approximate numbers, that you should retain no more significant figures than the number with the fewest significant figures. Now, from this calculation, now if you multiply 1.634, right? 6 what again? 643 gram by 0.26. Now, if you get the product now, tell me, in what significant figure will it be? First of all, which of them can wear the fewer significant figures? 0.2. So what is that significant figures? What is the number of significant figures there? 2, right? That means your answer should have 2 significant figures. So if you multiply it, what's the answer? Multiply 1.4 64 gram by what? No, not gram. I can multiply gram by gram. No, okay. What's the answer? 0.427 36 gram. And look at it now. So now, what should be the answer? 40, right? 2 significant words. Where's your goodbye? It was there. Okay, now put it together. Thank God. Peace, I'm all more. You will go and go. Guy, communicator. Can you go over? Now, so it's what? 0.43. So you round to what? To trace 2 significant words. Does it make sense? So the answer is what? When you get exam, you wear the cha. Lapulumi utua. Can make it random. Please note all these things, please. Note all these things. Okay, now let's look at under rule. This last one talks about two approximate what? Numbers. We are going to the one that talks about what? An approximate number and an absolute what? Number. Please know the difference, okay? No difference. The fifth one says, when multiplying or dividing an approximate number by an absolute number. When multiplying or dividing an approximate number by an absolute number, the result should be rounded to the same number of significant figures as the what? Approximate numbers. When multiplying or dividing approximate number with what? By what? So the answer should be in the same number of significant figures with the what? Approximate numbers. So if you have something like this, let's look at the example they gave here. If you have something like this, if you multiply 1.54 milligram by what? By 96. What's the answer? Raw answer. Raw is what? 147 point what? 84. 84 what? Milligrams. So what should be the answer? Are you sure? Check well. 1.54 times what? So what the answer? 147.84, right? So the answer, what is this? What number of significant figures do we have in the approximate number? 2, right? Approximate number. It's 3, not 1. Who said 1 now? Can you put 1 now? Can you put that in? Can you put that in? I'll go put that in. Ekulana. Do you see the board there? Are you sure? So, what is the number of significant figures of the approximate number? It's 3. At 1.54, it's 3 significant figures. 3 of us. We say that any non-zero digit is what? Is what? Significant. Hope you know. So this is what? 3. So that means this answer should be in 3 what? So what's the answer? 1 point what? 14 what? 14 what? 8 milligram. 3 significant figures. 3. 1, 2, 3. We have what? We have 147 point what? 84 milligram. This is the raw answer, right? But we want to put it to the same significant figures with the what? Approximate number. The approximate number, this 1.54 milligram is an approximate number. 96 is absolute number. So, and it should be in the same significant figure with the what? Approximate number. And every non-zero digit is what? Significant. So there are 3 significant figures, say 3 of us, 154. So this answer should be in 3 what? Significant figures. This is significant. But there's 8 here. Remember the rule of rounding. Because this is up to 5, you do what? Cancel everything here, call it 1 and put here. Because what? 14 what? 8 million what? Gram. So the answer is what? 148 what? Milligram. Kede dozie chine. Where is she? Kejeradi, Krebono. Kula a sị unu na-eme ise adịghị akwa mma. Na mgbe a ga-aya question. A ga-ayakwa question. All right. Now, we are going to somewhere else now. There we have a glimpse of dosing, how to dosing calculation. Now listen, let me just read, okay? Then after reading, I will explain. Now listen properly. The last one here says, oftentimes logic plays it. There are some situations you see yourself use what? Logic, common sense to know what you should do, okay? Especially in practical situation. Am I complicating? Now, oftentimes logic plays a role. For example, now, when a calculation is performed to determine the number of doses available from a medication or the number of drops to be administered to a patient, it is both logical and practical to express the answer in what? Whole units. Now, because you are told that if you are multiplying with an alphabet number, it should be in the sense you have figures with alphabet number. Because of that, now you now go to do your IT, and you know that after calculation, you know that there is no way in the whole world you can divide a bottle into 3. Can you have a bottle that is 1.37? A bottle? You know it's not possible now. There's no way you can get 1.37 for a bottle. Common sense will tell you that, oh boy, let me give these people so far now, because it's 1.37 bottles. Does it exist? So common sense will tell you, okay, if I give this for one bottle, they will not take up to the required therapeutic dose. True of us. Okay, even though I know that if I make it 2 bottles, and I cannot have half bottle, there's no half bottle here, unless maybe the drug is in a 100 ml bottle, and there is also the same drug that has 150 ml bottle. That one is okay. But if not, you have no choice. Give what? 2 bottles. After using, they should discard the what? The remaining, because you will not give them below the dose they should do what? Take. In that case, now you will be forced to give what? 2 bottles. Tell them, okay, just after this one is remaining, do what? Don't make sure you tell them to do what? Discard. Because if you keep quiet, some will keep taking it. So keep it after 2 weeks, they will continue again and take it. Or if the neighbor show us the same sign that they had, they remember that there's a drug that remained about half of the bottle 2 months ago. They match then did this thing. It was one that helped me that time. That is wrong. So you give them specific instruction after this thing. Discard it because you have opened it. If you stay for some time, it will lose its what? Efficacy, and it may even become poisonous to the system. You see, they listen to you after they do what? Discard the remaining one. That's what you can do. But following the rule of rounding, following everything, is 1.37 not 1? Yeah, following it the way it is, the way you were told. Is 1.37 not 1? Is it up to 5? Is 3.37 up to 5? Have you not seen that? Your common sense now, because of your practice, common sense I will tell you that you don't give them one because that one will not allow them, will not give them the therapeutic dose they need. True of us. Instead, give them 2. Let them get the proper dose and throw away the remaining. That's the only thing you can do. Am I competing? Especially if you are dealing with some drugs that are prone to resistance, like anti-infectives, anti-malaria, antibiotics, and name them. If it is a multivitamin, you may close either eye and give one, okay? Okay? After all, they take fruits, they can make it up. But if it's anti-infectives, make sure you get the exact what? Dose. Because before they talk about they specify the dose for treatment of a particular infection, they would have done the calculation properly. True of us. And so That's what you can do at that point in time. So have you not seen why I said that common sense needs to play a role here? That's why you don't follow exactly that thing we did in general mathematics the way it is. If you follow it, you have issues as a professional. You may not work. Use your common sense to know exactly what to do at that point in time. Like this last one now is trying to let you know that yes, you obey the rules, but when it comes to real practical scenario, if that has to do with doses, or number of doses, a number of drops, or whatever you want to give to a patient, try to do what? Make it a whole number. Having in mind what you want to achieve. Okay? Don't give sub-therapeutic dose. Instead, give the one, let it remain and deploy it away, no problem. You know it's a waste of money, but it's still better. Because look at it, look at, they will blame you too. Let's assume now, they now come. Maybe the dose, the total number of bottles. I should come. Please, give me some time, okay? All right, so that's what the common sense can help you do what? Achieve. Help you do what? Achieve. Well, I think we are through with the rule of rounding, right? Okay, the other thing there are just questions. Question number 1 says, state the number of significant figures. All these things are easy now. True or false? Are easy. Number 1 says, 1 full downs equals to 29.57 minutes. How many significant figures are there? 4. B, how many? B, 4. If you go online, they'll tell you 1. If you go online, they'll tell you 1. This number is denominated. It's not an abstract what? Number. It's 4. But if you check it online, if you just type 1,000, you see 1. But this 1,000, no again kanya na banya is 1,000 mil is 4. What? Okay, just get estimation. I in our last class I made mention of I told you something about the trying to draw there's a thin line between approximation and another. There rounding is a form of what? Approximation, right? Am I communicating here? But the approximation is more general, okay? It's more what? General. Yes. Now listen carefully now. You can be told to approximate to a particular, maybe to the type of questions we normally ask here. You just simple question. Approximate to nearest whole number, nearest 10, nearest 10th, nearest 1,000, nearest 100, all those things. Okay, they're not an issue. They're not issues. Then the point there is that we are even estimation survey is there no issues. I don't know what is troubling you estimation. That thing is simple. What's the problem? Bless him. Confusion. Told you confusion now. That's why it's a calculation now. If it goes, it's not our calculation. True of us. That's why it's a calculation. That's the beauty of calculation. If you see another question, you see it come in different dimension. You reason it out and get the answer. You see another one, it come in different what? Dimension. You reason it out and get the answer. Are you aware? Okay, take it. Forget this is what we are doing here. Are you aware that I have solved questions for complete 2 weeks? I didn't get the answer. If I solve, I'll keep it and go and sleep. Do other things. Next day I'll continue again. Solve. I'll just keep it and continue do other things. Continue until one day I may just be doing another thing. So maybe I may be doing another thing altogether. I may just be doing something else. I may not be doing something else. Want an idea will just come, bam. I will leave that thing I'm doing and go back to that. If you go to where I keep it, everything will just be remain where they are. I'll go and open it again. Try. It will work. I say, ooh, Eureka! You know. So calculation is not what is it called? No. If it's like that, it's no longer a calculation. True of us. It's no longer a calculation now, because it's a real. It's a kind of. If you bring it into real life now, it's brainstorming, trying to solve a problem. If something is so straight, it's no longer a problem now. It's not true. So no need for solution. That's why if you want to solve calculation, you see they call it what? Problem and what? Solution. And until you start thinking out of the box, thinking critically, you keep running away from it. But notwithstanding, I think that's the thing that's remaining there, right? In this topic. Phone guy, or every 2 seconds go there. I've explained to you what estimation is all about, right? Before, when I was doing an overview, I told that you say, okay, no problem. It's okay. Let's do it. You know, I promise you I will do it, Sha. Let's do it. Are you happy now? All right, let's go. It is important for pharmacy students and pharmacists or what have you to recognize the reasonableness of result of a calculation by performing an estimation of the answer prior to calculation. The approximate result may be determined. This will help to assure the correct dimension of the answer, including the critical placement of decimal point. The technique of estimation is demonstrated by, okay, now look at these numbers now. I've told you that if you know how to estimate, you play with numbers. You play with numbers. You play with numbers anyhow. To the extent that people will start thinking, is this one using juju? It's not juju. It's skills. Now look at this number now. Look at this array of numbers. If you want to estimate it, to help you to know exactly, okay, this is okay. This number, if you know how to estimate, maybe you are punching your calculator or you are doing calculation, and you end up you mistakenly, if you had already estimated the number. So if you had already estimated you may not get the actual number, just to estimate the right decimal place value of what the answer should look like. Number of figures expected to be in the answer. Now maybe you mistakenly wrote something else. You look at it, you be like, this is not what I estimated. It will take your attention back to check your work again. True of us. But if you not estimate it at all, you just the punch calculator, wow. You see yourself one day you punch calculator where you should have 7 million, you write 7,000 without even knowing. Without even knowing. Because you so much trust your calculator. If you forgot that your finger may punch 3 instead of 4. True of us. It happens. Even me say, why typing in system? You see, yes, where you want to type A, AB will appear there. It happens. True of us. And so this is one thing with estimation. Now let's look at these numbers. Let's use the number they gave here. They gave 7. Did that first one? Did they give you proper issue? Did you try the first one? Yes. Any issue with that one? So, What is that? Huh? What happened there?
Use that as an example.
I choose question I gave it to someone as an example.
No.
Okay, which number? A what? Number A? 42 times 39. Huh? Okay, as you see. Okay, 8431. Messi, copy. Second copy. When you are through copying that one, the one I'm saying now, you start looking for where to copy it. But why not allow the one you missed to stay? You focus on the one I'm saying now as the hot. You can't live your life by copying what somebody else copied. Because after copying this one now, you still look for the one I would do the one I'm saying now to copy again. No, it's wrong. It's not a good way to go. You've missed it, just leave it. Listen to what I'm saying now. Now, someone said we should we should estimate what? 8431 times what? 976, right? Now, if you look at this number now, immediately you look at this number, you don't need a prophet to tell you that the answer should be in tens of millions. You don't need a prophet to tell you that the answer should be in what? Tens of millions. Do you know how I got it? The three digits after the first digit, the three is only million, true of us.
Yes.
And the first digit of the two numbers will give you 10.
Yes.
It's tens of millions, first of all. Then you now look at the actual digit that should be there. Am I complicating? So this one alone should give you. You should be looking at. Around call it 70.
81.
9 times 8 is what? 9 times 8 is what? 72, right?
72, yes.
Good. 72. Then 4 times 7 is what? 28, right? 28, right? Good. 28. Now, if you check well, but remember that these 4 and 7, that 4 and 7, they are not in thousand. I hope you know. They are what? 100, right? So they should form what should be on top of that what? 72 million, right? Right? So if I am to estimate this in now, okay, sir. So if you watch the second digit in the two numbers now, they are in what? 100, right? So two of them can only give you what? Tens of thousands, not thousands. True of us. They give you tens of thousands. So this thing now, I can estimate this. I can just estimate this as I will add 72 million is base. 72 million is what?
Base.
The base already. 8 times 9 is what? 8 times these two digits are what? No, the last one, the second digit are what? 4 times 7, right? 28,000. 28,000. 28,000. Now if I like, I can stop at. No. Is it 28,000? No, I mean, see what I mean. The second digit in the numbers, the first number has 4 as the second digit, right? We have 431, right? Which is 100. It's 100, right? 100 times 100 will give you what? Tens of what? Thousand. Now here, but 1,000 times 1,000 and 1,000 give you tens of what? Million, right? So we only have 72 million as a block. So now if you do 4 times 7 is 28, we are looking at 28,000, true of us. If you add 28,000 to that 72 million, you have what? Two 8,000, is it tens of thousands or hundreds of thousands? Let me write this out. Look at the board. Because sometimes if we talk this in, they lose after. Look at this now. 8 what? 431 times what? 97 what? Look up. Please suspend whatever you are doing. This will give us what? 45. 72. This is 1, 2, 3. 1, 2, 3. 72 what? 72 what? Million. This and this is what? What? 28. We have 28, right? We have, remember, this is 1, 2, right? Remember, this is 4, right? 1, 2, 3, 4. You say it's 208,000, not 2. So it's 72,208,000. If you are permitted at 72,208,000, you are correct. You are what? Correct. Now, if you punch calculator down, what's the answer?
82 million.
What's the answer? The actual distance is what? 82 what? Million is what? 200 what? 500 what? 2 million. 5 what? 560. Now, there are some school of thought that will just take the first 2 digits and make them complicating and multiply and then add up other ones what 0. Am I complicating? There are some school of thought that they may divide this into 2. This now is more than 5. They add it, become what? 98. They multiply it 4 by what? 98. Then call it as what? 0. Am I complicating? Just look at it and get the answer. This may give you around that it's something million. 81 million. It's still okay. 81 million is 81 million is still okay. Remember I said that it should not be less than what? Remember the report I give. It should not be how many. Like now, this one we got 72 million something and 82. Is it correct? From what we said. Are you sure? Check well. Is that correct? What do you say about it? More than 10. Nah, I believe. Check well. Check well.
Your estimate must not be incredible higher than your actual value.
2 places above or below the actual value.
More than 2 places above or below. Two place values, right? Above. Now, look at it now. The difference between this and this is around what? 10 million, right?
Yeah.
Right? Is around what? 10 million. And this thing is in terms of, is it in terms of million or? Is in terms of million, right? This one is also in terms of what? Millions. Is it correct? Is it correct? Are they in the same place with value? Are they? Are they? Are they? This is tens of million. This is tens of million. Am I complicated? There is same what place value. Maybe you start getting after you know the larger the number, the place value, the larger, the wider the number of estimates he can do what? Accommodate. Am I communicating? Now, if you have something like this, maybe if you have something like this, you are supposed to estimate actual value of a number is maybe 12,490, and you go and start estimating 124. Maybe you mistakenly estimate 124. Will it work? This is what 100, and this is what tens of. So we have 100, we have 10, we have 100, we have 1,000, we have 100, we have 1,000, we have what? We have what? Tens of what? 1,000. We have 100, 1,000, tens of what? 1,000. Here now, this 124, they far below what? This one, even without even checking the rules, common sense will tell you that it's what? They are not even close related. They are not even close at all. Am I communicating? Even though this is not a wonderful, it's not a wonderful one. I hope you know. Even though our market, but it's not a wonderful one. And if you get something close to that, it's something perfect. Okay, but I just picked only with the first digits. Listen carefully. Let me give you a clue. Look at numbers like this now. You know this number is 4. There are 4 digits now. If you want to estimate, target the center. Okay, the center or a bit of, like if you have 8, 4, 3. We have 3 digits here. Am I communicating? If you want to get a good estimate, target here. Okay, target from 1, 2. Am I communicating? And if you have 1 maybe we have 128 times 1487. If you want to target here, don't throw this 8 away. Don't throw this 8 away. Call this 113. Then if you want to cut it here, don't throw this 8 away. Call this what? 15. You see that if you do 15 times 12, you get a good estimate. Just do 12 times 15 now. Do 13 times 15 and write it down. Then now do proper, get the actual value and let's see the difference. Do 13 times 15. Keep it. No, sorry. Remember you put these two places. These two places. Hope you know. There's one here. This is 0 now. You already call it 0, right? And you already call this one 0. So there should be 3 0 at the end of it. Hope you know. So we have what? 195 what? 190,000 what? Actual one is what? 3 what? 36. Then that 13 times 15 is what? 1 what? Then do 12 times 14. 1,800. 168. No, I mean sorry. Then you put the 0 now. 30. Oh, can you do you say anything here? Because you did not, because you just threw 8 away. It's a very big number to throw away. You landed yourself in what? 168,000 as against 190. So this one is a better what? Estimate. True of us. That 195,000 is a better what? Estimate. It's a better estimate to compare with this one. here I zero this 8, call it 0. Instead of carrying 1 and put here, just zero it and throw it away like that. Here I zero it and put it away. That's why I end up in what? 168,000. Huh? I gave 2 instances. I told you that if you have a number at least, it's better to cut it at least two first 2 what digits. I use the first 2 digits. Here I use the first 2 digits. But the number following this last second digit is 8. It's above 5. Before you zero it, take 1 and add 1 there. If you don't do it, you have a very low distance. So we use 12 and 14 alone.
We now was better 97 to 98. We got 81,480,000.
If you not do what?
Approximate
To 98.
Yes.
Okay, if it's only 97 and 84, you got what?
81,480,000.
81 million
480,000.
for it.
Then if you approximate it, you get 82,320,000.
If you get what? But what is actual value?
It's 2,286,000.
Then if you're going to get what?
It's 2,320,000.
2,000. But if you're not going to get what?
It's 1,480,000.
81 million. So which one is closer? Is it the appropriated one? No, which one is closer to the actual one? You know what I'm saying? But does it throw more light to what I'm saying here? Yes. Because this is up to what? 6. Is up to what? 6. What made that one to come below 2 million is that only the first digit was used. Like that in the multiplication. This one was just added. That's why we got for what we got. But if we split it into 2, at least 2. And also, if you watch now, we didn't, because here is not up to what? 5. That's why we zeroed it. And this 0 you call here, you must add it at the final. If you call this one 0, you add it at the final to the final one. Call this one 0, add it to the final one. But this one now, you have to add 1 there because it's up to what? 5. Yes. Sorry.
Now this one too bad. You make it also 8. You don't upside down approximate 10. That's 7.
What I want to do was use what? Only 8.
Approximate. That is 10.
Okay. You get 80 million.
Something like that.
It 80 million is not bad, but in some situations, hey, do you know why it worked? Because this number here is less than 5. In some instances, it may not work. You must have to upgrade it too. And even this one is up to 5 or 6. If you don't approximate it, you come down.
What of those values that have decimal?
Good here. I'm coming. We'll get there. So someone asked that question. Who else want to ask question? The same question? Okay, ask. What? This rate is 195,000. Yeah, it's perfect. Which one is that?
This is 431 times 97.
Remember I told you what led to 72 million was so split it. If you split it here, and make this one 98. Just multiply this 0 others. You're getting around 82 million or so. Can you write 81 million for 400,000 as the estimation? It's not bad. At least they are up to 5 zeros behind it. It's not bad.
Like this MM24 times like 8 approximately 8.
It's not bad. 82 million 320,000 is not bad. There are up to 4 0 behind it. It's not bad. At least 0 there is almost half of the full number of digits. It's a good approximation, estimation. Which one is that? Sorry. If you want to count, 1 0 is here already. Then 2 here. 3 zeros will be behind. Apart from the one you get from 13 and 13 times 14, 15, no. The extra 0 that will be behind is this 0. Because you call this 8 0. Then you call this 8 7 0. So we have 3 zeros are behind it. As let's hear Teacher Oma. I don't like this figure. Which one? Where? You know here, here. Do you know why this thing went so down? 8 is a very big number to just ignore. It's too big to just throw away like that, boom like that. That's why the thing now went down. There's 8 here. There's also 8 here. You threw away 8 here. Do you know how many digits you have thrown away? 8. That's why it went so down. And I won't take it as a good estimation. Because there's no relationship at all. Two of us is some at least. Any other question?
You did 9 times 8, which gave us 2,000. And then 4 times 7, which gave us 8,000. That's enough.
No, see, the issue there is that this thing now, instead of doing it that way, make it as a ball. 84 and what? 98. Because you know, if you're multiplying, every number has what you call multiplier effect. It's a multiplier effect than just adding. That's why you are getting that 72 instead of 80. Almost 10 million gap is too much. Even though if you follow the rule, it's not that bad, but at least your estimation should be close to your what? Actual, very close to your. It may not be exactly the same thing, but at least if you see your estimation and see your actual, it will actually look like what? Estimation. If they write 72 million and write 82 million and tell that they estimated it, will you? There's no. I'm not getting. Even the person who just wrote 81 million, at least it's better. Even though some smart guy will just go and write it. But they want to catch you, I'll just stay to your work. Stay to your work. I want to see how you got it. So estimation is always just a bonus question. It's not a serious question. Because people can just close their eyes and okay. But the people can just point their calculator. Okay. If the answer is for 82 million, okay, let me like 80 million. Or then it is like a bonus.
Now that's 8431. Open up 5 for the ever trade. Let me make you approximate.
Yes. So now, another question. Division.
Yes.
Where? So after this division, we are done with this topic, right? Yes. So that means okay, that's good. We are done now. Number what? 2D. 2D or 0.7. Okay. We have a zero biotic here. We have a zero biotic here. What is xenobiotic? Huh? Not living thing. It's not true. Look it up. Look it up. Look it up. Xenobiotic. X. X. Xenobiotic. Look it up. This is how you learn all these things. So it will enter in small. Xeno. X. Xeno. X. X. E-N-O. Xenobiotic. Xeno. Xenobiotics. Yeah, of course. Yeah, you can. It must not be lower than it can be higher, but what matters is the difference between the two of them matters.
Because I did a mistake. This 996 axis and
Huh?
as in that 976, 976 axis I attached to that cells.
Okay.
So after the mistake,
Okay. Can you wait this one at the end? What do you get at the end? All right, let's. I think this question now will solve a lot of.
division.
Okay, division. Okay. That's 0. You know, if you take all these zeros, they're about 8 zeros, right? Or 7, 8, right? No, I mean the digits. Sorry, I mean digits in the actual value. They are up to 8 digits now because it's tens of millions. So half of it already is 0. It's a good estimation. At least you see, there's a figure you will get. If you like, let it be close to the actual value. There's a figure you get, and you know that you did not do it. You just got a number that is close to it and gave me. If I see so, if you actually did it as in Lufa did it, I will know. But it had no specific what answer. Your answer may not be sent with another person. But if you manipulate it, I will know. And I'll catch you. Now look at this one. It says, this one says, yeah. It's good, but I don't like that. It doesn't look like an estimate of that number. It looks like something else. Get something that is at least close to the what actual what. Okay. Now let's look at this one. 0.0726 times 69 what 51. Now look up. Look up. Look up. Here is what? You can do a split from here, okay? You can now split from here, right?
Yes.
Good. Are we together? Now, if you look at this one is you can make it 70. It's okay. You can make it 70. It's okay. It's not bad. Here is what 70, and here is what. This is what 0.07 what 3. This is 0. What? 0. What? 073. Do you know I can personally forget this 5. Do you know why? What you are multiplying it with is just at borderline. Look at 6 here. Are you with me? Look at 6 here. Is at borderline, but if it's okay, let me make it no problem. Just look up. We have what? 0.073 times what? 70. Of course. Now you may not even need to punch calculator here. Just put this thing in the right what? Place value. This is what? 1,000, right? This is what? 1,000. So 73 times 3 square what? 3. 3 of us. 3 of us times what? 70, right? What's the answer? 5 point what? At the end, right? What is the actual value?
Actual value is 504.642.
400 and what?
504.642.
500 and what?
4.
Point what?
6426.
6426. Remember here.
6426. 64.
504 point what?
6426.
64 what?
26.
Now look at this one now. Yes, remember, don't forget that there's something we left here. Hope you know.
Yes.
Remember, and there's something we left here. Hope you know.
Yes.
This one is what? 0, 0. This one is what?
0.
No, let me. I like this. Let's solve this. I like this. Let's solve it. 0.0 what? 726 times what? 6915. Okay, we split this right. Here we got what? Here. Is that what? 0. What? Times what? 70. So what are we keeping aside here? Here we keep aside the what? Here, Uncle. What is here? 0. Okay, let's continue. All right, let's go. You see that there are 3 zeros there, right? So we have what? Here is what? Remember that this is written as what? Just multiply. Let's not waste our time. Just multiply this. 5 point what? 11. So what? How do we now reconcile this and this? Where? Is this ending with this one? I like this question. This question get weird of things. Okay, weird of things. Oh yeah.
0.0005. No, it's 0.
You say what? Say it again.
500.
Ethiopia where? Ethiopia where?
500.
Ethiopia where?
Point after 50.
After what? Someone said I should do this movement. Oh yeah, how do I do it? Tell us how we do this movement. Tell us how we do this movement. How many decimal movement? 3.
Yes, do 2.
I should do 2.
Yes.
To where? To right.
Yes.
1, 2. I have 5, 1, 1. Point what?
0. 3
Point what? Point 00. So why do I need to do the decimal movement? Why? Why do I need to do decimal movement? Why? So that what will happen? Are you manipulating or are you sorry? What are you doing? What is the reason behind what you are saying? I want to hear the reason behind what you are saying. That's what I want to hear. Okay, so that if someone sees it, you know that you. Is what? No, this is not. This thing is a good estimation, no? For real. 504, 511 is not bad. Okay, remember this has what? Decimals. Okay, it's not bad completely. But I want to know why. My question is why should we do 511? Remember we got. Remember we multiplied this and got what? 5.11. So why must it be 511? You say what? Say it.
So it's the decimal place with the actual.
Look at. Are we together? Are you aware? This thing you broke, this thing you remove here. This thing you remove here is actually by this thing is actually 0 and what? And 0, right? Yes. Right, remember. Now, if you take the actual value of what you remove, what is it? What you this is okay. Now let me keep this now. Let's look at whole numbers now. Okay, if you have, let me use whole number to explain to you something. You have let's assume you have 726 times what? 695. Okay, 6951. So what actually is what? 50 what? Sorry. Correct. 5 what?
5046.
One person, please.
5046.
One person. 6. 26. Now let us estimate it. We have 73, right?
Yes.
This 73 times what? 70. What's the answer? 511. 511 what? 0. Now remember here, you put this 1, 2, and 3, right?
Yes.
Put what? 1, 2, 3. Right? Good. Now, compare this with this. Compare this with this. Now look up. If you want to solve a thing like that, are you aware that this is certain? Are you aware that this thing here, is certain as saying is this one here? Sorry, this thing is certain as saying 726 times 3 power what?
Yes.
Times 3 power what?
-2.
Is it -2?
Yes.
Is it -2?
Yes.
Huh?
Yes.
It's -2, right?
Yes.
Are you aware? Good. Now, but remember that you have removed this 6. You have rendered it what? Useless, right? You took one from it, right?
Yes.
So the decimal point will come here, true or false? I will have what? 7 what? 3 times what? 3 is power what? Minus what? Minus what? Minus what? Decimal movement is moving to the left. It's moving to the what? Left. So what do you add there? See where we started. This thing that you wrote here, this thing now, is it actually 726 times 3 power 2 minus 2? Is it?
Yes.
Are you sure? Very, very sure. 726 divided by 100. 7.26 is wrong. What are you even saying? It's wrong. So the decimal sample we did here is a waste. This is wrong now. Look at it. The state is the same. This is wrong. Good. This one minus what? Look at it now. Look at this. 1, right? 2, 3, 4. The decimal point is here now. It's minus what? 4. So here should be what? This one what? Minus what? Where is it again? Here up here? Yes. Minus 4, right? Yes. I'm teaching something now. Just listen critically. Look at it now. This is written as 726 times 4 minus 4. But you have removed this. You moved the decimal point here, and you discarded this one, right? Yes. And we got what? 73 times 3 power what? As you move to the left, you add 1. The add 1 becomes what? Times 3 power minus what? Right? Yes. So all these 73. This 73 now. Couldn't use lever. Can you use lever? When what again? When take the 5 point what? What again? 5 point what? 1. True or false? Wait, let me come here. Look at it now. 70 times what? 70 is what? 511, right? Right? Are we together? Yes. Good. Now here, what if you now add times 3 power minus 3 here? What will happen? For it to be the same thing with this one. True or false? True or false? Watch out. Here is only 73, right? Times 70, right? And you got what? This. And you added all those things and got what? This, right? Now what can we do to this 73 to be the same thing with this one? We add 3 power what? Times 3 power what? Minus what? 3. Remember, we are working without 73, right? So if we times it times 3 power what? Minus 3. This minus 3 will now be eating these zeros, one after the other. It will eat the first 0. No. How many zeros? It's 3, right? Sorry. This thing will eat all these zeros here now. This one, minus 1, will eat what? Because we want to neutralize this minus, right? First 0 will go, right? Second 0 will go. And third 0 will go. The answer is what? 511. I'm trying to explain to you what you are saying here. That this issue, you didn't know how to put it. Someone was explaining it. That's why I went through all these things. To explain to you that actually, these 3 zeros you remove here. These 3 zeros you remove here. They have impact here. Am I communicating? In fact, 1 0 there, 2 0 there is positive. Hope you know. Are you aware? They are from here. Right? They are from here. Because of this 0 here, this 0 here, this has rendered whatever here is here not contributing to this number. This 2 0 here will now, because this 2 now is like, how do I put this in a for you to understand? Ask question.
I'm not sure saying you should put decimal point after 1. So
I feel like according to the rule you gave us in round one, you said if approximate number is multiplied with its absolute number, give your answer in the same significant figure with the approximate.
Okay.
That should be the reason why it is 511. What we got was 5.11.
Okay.
Then the 3 zeros are meant to add to it.
Okay.
And then she was not like you should make it 511.000.
Okay.
So I feel like and our approximate number here, we have 3 significant numbers. So
Where is it? Which one?
approximate number is 1.0726.
Okay.
We have 3 significant figures.
Okay.
And in the rule, you said when approximate number is multiplied by absolute number, you give your answer in the same significant figures with the approximate number.
Okay.
So I feel like the reason why it was shifted to 511.000 because I'm trying to leave our answer the same significant number following the rule around.
Good. See, every rule comes from there's what we call first principle. There's no rule that just appear like that one. Every rule comes from a first principle. So what I'm explaining here now, I'm trying to point out where it came from. That rule is okay, it's working. But I'm trying to let you know that it comes from this. She got it too, but she doesn't know what led to that. There should be movement here. 1 and what? 2. So I'm talking about where that. I'm trying to tell you where this whole thing came from. This 1, 2. Remember, we cut off this. Remember, we cut off this, right? And this we cut off. Remember, if you cut off, you have to add it back to the what? To the number. So the 1 0 here. As you add 1 0 here now, this decimal point to do what? Shift. As you add another one, it will do what? Shift. You have what? 511. But here now, what I'm trying to, where I'm going is, why did this not contributing again? This one we moved here and call it 73. Why is not contributing again? And even if you must contribute, will you contribute like this or like this? Are you with me now? So that's what I was trying to explain when I started doing all these things I'm doing. When I'm done with it, we arrive at the same what? 5 what? 1 1. Okay? Now the basic thing is this. The basic thing is this. So provided that you have taken care of the standard form here, you have taken care of the index part. This thing you left here has no contribution again in what happened after the what? Calculation. Are we together? Are we together? It has no, the one that matters now is this one. You threw away just like that. You have taken care of this by moving this to what? To what? The standard what? Form. Because this thing now, this 0.7, remember this contributed as you move the decimal point. That is why it ate up a 0 already here. Remember, this thing now you remove, ate up a 0 here. Because of the what? The decimal place, the place value. So when you now want to, because if you multiply 500 times 550, you have 25. You start adding 1 to 3, right? 1, 2, 3. True of us? True of us? Good. Now this thing you added here, 1, 2, 3. 1, 2, 3. You multiply this 25 by 1,000. Are you together? Are you together? And get what? Now that's why that means of this 0 you added there. But this 0 now, you added here. This 0 now is 100. Hope you know. Are you there? So if you multiply this 5.11 by 100, you are getting what? 5 what? 1 1. Are you together? Are you together? So that's basically what happens. But this one here that you threw away contributed in the calculation when you are punching your calculator. It dealt with this 0 here. This one you moved dealt with the 0 here. That's why you don't come here again and start adding it. If not, you would have said, okay, let it be 1,000, which is not true. Am I communicating? So that's what I'm trying to explain. But basically, using the what is it called? The rule of rounding, just simply say this multiplied, you get it, it's okay. But one thing with me that if I'm thinking that I like taking it from the first principle, so you understand it, so that in case you forget, a rule is a deduction given to you when other things has been solved behind. You don't even know how they arrive at that particular rule. Am I complicating that? If you only have it at your mind, have it at your mind, you see that at the end you may forget certain things. You know you are differentiation, right? Did you do differentiation from the first principle? We had taught that. Okay. You just know product rule. Do the S is in can. Okay, it's okay. So I understand. But if you do differentiation from the first principle, you see where all those things came from. They came from a principle. They came from somewhere. But that is not your field anyway. But you just for you to know, understand. That's why I'm doing this. But the answer is what? 511 is not bad. Okay? 511 is not bad. Now, if you not decide to, if you not decide to leave this 5, okay? If you decide to leave this 5 and just use 69 and what? 73. What will you get? What will you get? Just use 69 and 72. What will you get? 5 what?
4968.
4968. So it's what now? What will it be? Sorry, we are dealing with this. Zero what? 0.679 times what? Sorry. Now, so what the answer? 4 point what? 96. It's same thing anyway. You do what? 1, 2. You have what? 496 point what?
5.0.
Is it before 96? Who did 7? Is that what I said? Okay, sorry. I mean, my hand is not up there. My mouth is saying another. I wrote 0.73. I have 99. What is that? 5 what? 5.0 what? 37. So we have what? This, right? Yes. I have 5.0 what?
37.
This one is better, right? Yes. Right?
Yes.
True of us?
Yes.
It's better, right? Yes. So this is the power of what? Estimation. Now, someone talk about division. Let's look at division. Give me an example. Let's where?
1.074.
One works.
1.074.
I'm coming. One what?
0.74.
Okay, 1.0.
745.
I'm coming. Should I clean? Huh? Let me clean here. It's not easy. Okay, now look at this. You say 1 point what?
1.0745.
Divided by what?
500.
500. Right? Now look up. Hello, are we together?
Yes.
Please look up. Look up. This thing now, look at it now. Look at this thing now. You can actually get to 1.1. I hope you know. Are you aware?
Yes.
Are you aware?
Yes.
You can get 1.1. Are you aware?
Yes.
Good. Divided by what? 500. 500. Who's talking? The principal. So we have what?
0.0022.
0. Point what?
0.
0. Point what? 0.00 what? 22. What's that? What's that? Okay, look at the marker explain.
1.0785.
No, leave it at 1.1. Sir, 1 is there. No, I'm not. 1 is there. I using it. No, it's not for students, it's for lecturers. 1 is there. I think 1 is there. It's not there again. Look at it. There was 1 here. In fact, we use it to cover this place. Now that means yeah. So what's the answer? No, get the actual answer. The actual value is what? The actual value is what? Divide 1.074 by 500. 2 point what? 2.149. Sorry. 2.149 times 3 square what? And this one is what? What's that? Carry it. And this one, put this one in the standard form. 2 point what? Minus what? That is how my lecture looks. If you shift the list and turn again, you see it and that's not the board. Only 2.2. Is it, how do I do? Okay, look at it now. Okay, it's okay. Let's take it slowly. People should give marker now. Do I produce marker here? If you give marker now, we see another marker. The question says what? 1 what? 0.0 what? 745. Divided by what? Now, one thing you should know is this. Everything here, unlike this one, everything here, if you accumulate them, you cannot put them back again because this thing is unit. Hope you know. This is it the highest place value is what? Unit. True of us.
Yes.
True of us.
Yes.
Yes, so there's no zero you are adding anywhere again. True of us. Because it's units. The highest place value in that number is what? Units. Had it been is 10, after division you add that you multiply by that 10 and get the final answer. True of us. But this one is units, so you're not multiplying with anything again. Just divide it straight and get your answer, okay? Now if you divide this by 500, you can do this. I remember we decided to take the 1.1, right? Accumulate, right? So we are doing 1.1 divided by what? 500. True of us?
Yes.
This is let's put this in standard form without you push it. Close it. Now look at it. This is just 1 times 3 raised to power what? Minus 1. Divided by what? 5 times 10 raised to the power what? 2. Abria. 1 over 5 times 10 raised to the power minus 1 times 10 raised to the power minus what? 2. True or false? True or false? True or false? True or false? Who is lost? Haha, this is lost. Even Mirabel is also lost. No, this is standard what we have done now. We got 1.1 divided by 5. I'm trying to teach you how you can see without moving a calculator an inch. This 1.1 divided by what? 5. You know that this 1.1 is sitting as saying 11 times 10 raised to the power minus 1. True or false? Divided by this one is sitting as saying 5 times 10 raised to the power 2, right? Using law of indices now, if you want to divide, this will divide this will come out, right? Then this 10 raised to the power minus 1 divided by 10 raised to the power minus 2. This will turn to what? Minus, right? This will turn to what? Multiplication. True or false? Is it clear now? So you keep going. Just divide 11 divided by 5 is what? Times 10. Multiply the 11 divided by 5 is what? 2. You put point, right? That remainder is what? 1. What base are you working on? Times by 10. Continue dividing. 2, right? 2.2.
Yes, sir.
Times 10 raised to the power what?
Minus 10.
This is the estimate. 2.2, but the actual value is 2.149, right?
Yes.
2.149 times 10 raised to the power what? This is a perfect estimate. Very perfect. It's a perfect estimate. Number what? 3A. 3A says what? 171 divided by what? 19. Okay, let's go. Is it 9 and 19? It's 19, right? Okay. Okay. This one what? Divided by what? 19. Are we together? Okay. 171 divided by what? 19. Look up. Here is what? You can decide to work with this. Are we together? You can decide to work with this, right? Here 17. Over what? Over what? 2, right? 2, right? Remember there is a 10 here. Hope you know. And there's also 10 here, right? Hope you know. True of us, the 2 10 will cancel each other and go their way. The answer is what? 8.5. Is it clear?
Yes.
Is it clear? You did this one 2 here.
But 8.0.
8.0. If you give me 8.0. But remember, I said that the smaller the place value of the number you are giving, the narrow the gap should be the gap between the what? Actual and the what? Estimate. Okay? 8.0 to 9 is a very big number. I hope you know. With respect to estimation, are you aware? It's a very big number. It's a very big number. Yes, it's 9. This estimate, 8.5 is estimate. Because you know here is 171, right? Divided by what? 19. Here, this is not up to what? 5. You call it 0 and put it here. Right? Remember? Making it 10. Or you hope you know that by calling this 0, you have removed a 10. Hope you know.
Yes.
And that 10 is at the numerator, right? Yes. In this one again, calling this one 2, you are also remove your 10.
Yes.
Don't forget you are dividing. So the 10 will cancel each other, right? You are left with what? 17 over what? 2, which is what? 8.5. This thing, if you are doing so, this thing, you'll be there. This thing will give you an estimate of what thereabout. This thing should be okay. After this one, I'll go and rest. I've tried.
3E.
Three what? 3 what? E.
Yeah.
458.4 divided by what? 8. 458 point what? 45 what? 458.4 divided by what? 8. Look up. Hello, are we together? Are we together? Here now, I can decide to cut it off from here. Okay? Are we together?
Yes.
So if I cut off from here, I have 40. Remember that if I cut it off from here, what did I remove? Is it 10 or 100? Is it 10 or 100? Because the decimal point is here, right? This is 10 and remove. Hope you know. So we keep that 10 by the side, right? There are nothing else. This unit, so there's nothing to add here again. So nothing can be varied after the result to multiply by 10. Okay. So we are working with 46 over what? 8. What's the answer? 46 divided by 8 is what? 5 point what?
75.
Multiply by 10. What's the answer?
57.5.
Actually, it's what? This is a good estimate. It's a good estimate. Last one where? 3B. 184 divided by 2003. One 84 divided by what? 2 3. Now remember, are we together? Are we together? Yes. Here now. Here we can. There are many ways you can work on this one. You can decide to, if you like, you can take out 18 and 2. Okay? So if you take 18 and 2, you get here now you are remove what 10 here, true of us. Is it 10 or 100?
100.
No, 10. If you take 18, you remove 10, right? Divided by, if you take 2 here, you remove what? Over what? True of us. So let's now, this is 0, see their value here, right? So let's now work on this. 8 divided by 2 is what? 9. Remember here. Here is what? This is 0.1, true of us? Or 1 over 10. Up here? Right? Then multiply by 1 over 10. We have what? 9 over what? 10, which is what? 0.9. Punch it. What's the answer?
The actual is 0.08.
0. What?
08.
Sorry, this is 3, not 2. 1, 2, 3. Here is what? 3, not 2. Sorry. 1, 2, what? 3. It's 1,000. Are we together?
Yes.
This is 1,000. So here should be what? 1 over 100, right? Right? So this is 0.0 what?
Yes.
9. What's the actual?
0.08.
0.08.
0.08, yes.
0. What? Cheba? Subafa? Ijaifum? Is what? 0. What? 09. Okay? I think we'll stop here. We've tried. In our next lecture, we'll start from where? No, lecture is going on. Quiz is going on. No. Our next topic is what?
Ratio, proportion,
Ratio what?
proportion and variation.
And variation. Okay. Our next topic is ratio, proportion, and variation. Now, please, remember what I told you. I am prepared for my quiz anytime. I may just, if I see any single space, I'll just enter your class. If there's nobody there, I will always I will list 1 to 100. We are going to topic what? The third quiz, right? The C8, the third one, right? So I'll just write from 1 to 100 and fold it and come here. It will always be in my pocket. Once I enter, boom. And there's nobody, I'll just come. Hey, come. Pick. You pick. Whatever you picked. From that 100 questions you have, that's where you. If you pick number 20, you come out here and they solve number 20 for us. That is how we do it. Are we together? So that's what we do from now onwards. Because we need, and they see, we are not waiting for anybody again. See, our quiz will just be going on its own. Lectures will be going. I'll give you the questions. If I were you, what I will do is this: whether we have done the topic in class or not, solve those questions. Check the material you are given on each topic. Try to solve the questions. If you don't see, browse, solve, find the answer to that question, solve them on your own. That's why I gave it to you. So if I may finish the third quiz. Maybe one day I may just come in and there's nobody is here. Nobody is here. I may just stand and start calling you. Come. We may finish the third quiz that day. Tomorrow we may not have even finished the fourth topic. We enter quiz. Is a C. I hope you know that is an assignment. Is an assignment you are giving your course material. You have excuse me. I want to correct an impression. That's why I'm saying this. The impression I want to correct is that this is your CA, is your assignment. I gave you the question, and I'm telling you that the question you are going to come here to solve will come from those things I gave you. Am I communicating?
Yes.
Now, I'm not going to change a figure in that assignment. If I call you, that's what you're going to solve. So, Kosi demands that if you wait until we do the topic before you go and start solving the question, you're wasting your time. Because now that you pick, we faster, three of us, we may finish the third thing even in 2 days, and the following day I may come in and enter the fourth one. Whereas we are just starting ratio. So that's why you should study those questions. Anyone you don't understand, look at material, ask your friends, try to know the answer to those questions. Ask me what? Can you ask? See, thank you for that question you asked me. See, if you are giving assignments, you don't go back to the person that gave you assignment and ask the question on assignment. What you ask is maybe what you don't understand in the question, okay? In the question, let's assume that there's something that is not clear in the question. That one is, but not asking the person question he gave you to go and research. No, it's wrong. Or the very, very wrong. Because the person gave it to you for you. The person knows it, right? But don't you need to go and do what? Research and learn it. Then you come back to the person again and start saying, no, about the assignment now. Three of us, your teacher give you assignment, you go and come back and start saying, it's wrong. You're laughing. That must be why you should do what? Why then you are studying? No, it's not just to come to class. That's why if I see making notes, I say, I wonder if I'm making notes, have they finished what they should be reading? I don't understand it. Sometimes I don't know. Sometimes I like telling our stories just to make you understand. If Abanuzo, when you come to class, you're making noise. No, now the person the person you are looking up to, or you want to subdue, we call it subduing. Looking up to and subduing. If you want to do a competition, do a healthy one. The healthy one is that this person Amangam is a healthy competition. Not by going to do something stupid. Fair play by doing what? Studying. You enter class, you look at them. Okay, he's reading. You go and do what? Study. You are in the same hostel. You are in the same room. If you don't have any point, any person you look up to, you look as this person, either the person you want to learn from, or the person you have told yourself, no, I'm this school. Then you need to really work on yourself. Healthy competition is what? Is allowed, and it helps you to grow. Healthy one. Even though you are maybe, I don't know if people have watched some of the films, some of these either Korean film. Yes. Who is a Korean fan here? Now, if you watch most of their films, where they fight or do something, you see, this is your academy. This is somebody you want to defeat, and maybe in the point of trying to defeat somebody else, go and do something bad to the person. You go and start fighting. Why did you attack him? That he's no longer there's no joy there again now. You went and they attack him. No. It's two of us that should do what? Let it be a fair what? Play. And here now the fair play that you should go and do what? Sit down and do what? Wait. Two of us, you sit down and do what? Study. So please, I don't know. Maybe Nuna Gujigo. I don't understand it. Una Gujigo. Please stop making noise in class. When there's no lecturer in your class, that's why I fix my listen. Once I don't have anything in my office, you see me here, guru man, come here. Hey, come. You may be going to buy up. I'll call you back. Come to the board. All right, thank you very much for your attention. God bless you.